telemetry conditions, which would primarily be for corridor control, controlling the flight path angle at entry. And the current predicted splash time in the Pacific is 195 hours, 17 minutes, 25 seconds. At the present time, Apollo 11 is 172,654 nautical miles from the Earth, traveling at a speed of 4,017 feet per second. We estimate that the spacecraft will be halfway home at a ground elapsed time of 159 hours, 53 minutes, 43 seconds. At that point, the spacecraft will be 145,583 nautical miles from the Earth's surface, and we'll have completed half of the return trip, measured from lunar orbit insertion to splashdown. We also have another figure that would be for the time at which the spacecraft velocity is equal with respect to both the Earth and the Moon. At that point, the velocity will be 4,300 feet per second with respect to both bodies. And we would define this as the equal potential point. That will occur at 155 hours, 30 minutes. And at that time, the spacecraft will be 156,874 nautical miles from the Earth, 52,543 nautical miles from the Moon. We're now 1 hour, 28 minutes, 26 seconds from ignition for the mid-course correction 5 maneuver. Apollo 11, this is Houston, over.
Roger, Houston.
Roger, if Neil has a free minute, we've got a question or two regarding the CO2 partial pressure and water in the suit loop discrepancies noted yesterday, over.
Go ahead.
Roger, 11. Was water noted in both suits or only in yours, Neil?
I think only in my suit.
Okay, can you locate that occurrence for us in time when you first noticed water in the suit, either by mission time or relation to any particular event?
I think it was after insertion sometime, Bruce. I don't remember exactly when. It was when we were in orbit and after we took our helmets off.
Roger, did you call it to us when you first noticed it, or was it sometime after when you called it?
I guess it might have been probably 20 minutes after I noticed it that I mentioned it to you.
Roger, was this noticing the water accompanied by erratic CO2 partial pressure readings, or was that a separate problem? Over.
Well, the water problem evidenced itself before we noted any erratic motions of the PCO2 gauge.
Roger. And what was the relative sequence on selecting water separator number 2 and the secondary CO2 canister? That is, did you go to the secondary water separator first and then secondary CO2? Over.
I believe we went to secondary CO2 first. Secondary lithium hydroxide.
Roger, we copy. And was there any change in your suit loop?
No.
Go ahead.
I should mention, Bruce, that when I went water separator to secondary, I didn't notice any change. But about after 15 minutes or 20 minutes, the water stopped coming out. So maybe that was just water that was already in the loop that was still blowing out, but the secondary water separator was operating properly.
Roger, did you make any changes in the suit loop configuration after you went from the egress mode to the cabin mode after insertion? That is, in particular, they're interested in knowing if you recall changing the diverter valve to position to egress at any time while you were on the secondary canister. Over.
No, I don't believe we did that at all, Bruce.
Okay, 11, thank you. That sums up our questions for now, and we'll crank these back into the engineering pipeline and see what we can come up with.
Okay, are you satisfied that the CO2 circuit breaker was in on Jettison? Over?
Say again, please.
Roger, on Lem Jettison, are you satisfied that the CO2 circuit breaker was in? Over?
Yes, it was in.
Roger, could you confirm that? I thought there was some question after we got into the command module as to whether that had been left in or not. Over.
Roger, 11, it was in and confirmed in, and the readings after jettison stayed about 0.1 to 0.2. This is Apollo Control at 149 hours, 41 minutes. We're now about 49 minutes away from the first mid-course correction on this trans-Earth leg of the Apollo 11 flight. That maneuver will be a 4.8 foot per second burn of the spacecraft reaction control system thrusters, and is scheduled to occur at a ground elapsed time of 150 hours, 29 minutes, 54 seconds. At this time, Apollo 11 is 171,017 nautical miles from the Earth, and the spacecraft velocity is 4,043 feet per second.
Apollo 11, over.
This is Houston, over.
Roger, I wonder if you noticed any change in the biometry turn you're getting, over.
Negative, Buzz. It still looks kind of bad. Apparently when you move around, it's cutting in and out. Have you checked the little electrical connector where it goes into the signal conditioner? Over.
Yes, they're all just about as tight as can be. I'll tell you what, I'll take them off and put them back on again. See if that makes any difference.
Okay, if you would, at your convenience. We'll be watching it down here.
This is Apollo Control at 150 hours, 4 minutes. Telemetry data at this time shows the spacecraft in the proper attitude for the upcoming mid-course correction maneuver. The crew will soon be verifying their attitude by taking a sighting on a star through the sextant, and then be running some tests on the guidance and control system and the reaction control system before the maneuver takes place. That burn now scheduled to come in a little over 25 minutes. Apollo 11 is now 170,102 nautical miles from the Earth, and the spacecraft velocity is 4,058 feet per second.
Apollo 11, this is Houston. We'd like you to try acquisition on the high gain antenna for us at pitch -90, yaw 270, over.
Roger it. That can work.
Roger out. This is Houston. We're showing about 6.8% on wastewater on our telemetry now, over.
Okay, got about 9 up here, over.
Roger out. Houston, we're standing by for your burn. Everything's looking good from down here.
Thank you, Bruce. You got about a minute and 20 seconds.
Roger, we can chirp.
One minute now until mid-course correction number 5. That will be a 10.9 second burn of the spacecraft reaction control system thrusters, giving a change of velocity retrograde of 4.8 feet per second. The primary purpose of this maneuver will be to control the spacecraft flight path angle at entry interface. We're now less than 30 seconds from the initiation of the burn. They should be burning at this time. And we show the burn off.
Houston, you copy our residuals?
Roger, we've got your residual CO counter reading for us.
Delta BC is plus 0.2.
Roger, plus 0.2.
Yeah, it was actually plus 100.2. Okay.
Okay.
That mid-course correction was performed at a distance of about 169,000 nautical miles from the Earth. The spacecraft velocity 4,075.6 feet per second. This is Apollo Control at 150 hours, 35 minutes. Our telemetry data here on the ground shows that mid-course correction maneuver just about nominal, burn duration 10.5 seconds. Prior to the maneuver, we were predicting a splashdown time of 195 hours, 17 minutes, 25 seconds. We expect there will be some modification to that after we've had a chance to do some tracking following this mid-course correction maneuver. Apollo 11 is now 168,843 nautical miles from the Earth, traveling at a speed of 4,078 feet per second. And we're continuing to see a very slow build-up in the velocity.
Houston, Apollo 11.
Go ahead, 11.
Roger, we're in PTC attitude, and would you please give us a call when our thruster activity has subsided sufficiently?
Roger, stand by. Apollo 11, this is Houston. We're going to hand over from Madrid to Goldstone at 151 hours even. If you should lose lock on the high gain at this time, you may reacquire at pitch -45, yaw 270. Break, we're still watching your race, over.
Okay, thank you.
Apollo 11, this is Houston, over. Apollo 11, this is Houston, over.
Go ahead, Houston.
11, we're still seeing rates on your spacecraft above those that we'd like for in a continuation of the PTC mode. We're still monitoring it, and we'll advise you when it's settled down, over.
Okay.
This is Apollo Control at 151 hours, 11 minutes. The crew is presently setting up the spacecraft for passive thermal control. Once it stabilizes out, it'll begin a slow roll rate of 3 revolutions per hour to maintain temperature control. At the present time, Apollo 11 is 167,448 nautical miles from the Earth, and the velocity is 4,101 feet per second.
Apollo 11, this is Houston. Your go for the spin up on PTC, over.
Thank you. Houston, Apollo 11, over.
Go ahead, 11.
I just didn't like it that time. When I got down to the entry 27303 enter, it took off and roll at a high rate in excess of 1 degree per second, over. So I've stopped it now, and we're going to have to go back and do it over again. I'd like to try to find out the reason why it did that.
Roger, you might as well start setting up for it, and we'll be working the problem now.
Okay, do you have us on high bit rate here now?
That's affirmative.
Okay, good. I'll maneuver back to PTC initiation attitude while you guys look at the data and see what you think.
Roger.
Houston, Apollo 11, I think the reason is in having 1620 on the disk key during the subsequent entries. Or at least that's one possibility.
Roger, we'll check it out. Apollo 11, this is Houston. While you're waiting for the CSN to settle down and for us to look at the tapes on your latest maneuver, would you feel like answering some more questions with relation to the lunar surface, over?
Go ahead. Go ahead, Bruce.
Roger, for $64,000, we're still trying to work out the location of your landing site, Tranquility Base. We think it is located on LAM-2 chart at Juliet decimal 5 and 7.8. Do you still have those charts on board, over?
stand by when they're back.
Roger, you may not have to unpack it. The position which I just gave you is slightly west of West Crater. I guess it's about 0.2 of a kilometer west of it. And we were wondering if Neil or Buzz had observed any additional landmarks during descent, lunar stay, or ascent which would confirm or disprove this. One thing that we were wondering about is that if you were at this position, you would have seen the cat's paw during ascent just up to the north of your track. Over.
We were looking for the cat's paw too, thinking we were probably downrange beyond those Big Z. But I think that it's likely that that might have been West Crater that we went across in landing, but stand by. We're hoping, Bruce, that our 16 millimeter film was working at that point in descent, and we'll be able to confirm our touchdown position. We thought that during ascent we might be able to pick up some recognizable objects close to the landing site, and we did see a number of small craters and crater rows and things like that, which we may be able to pick out after the fact, but we haven't been able to yet.
All right, Roger. And the next question from our panelist was Buzz. We recall that he reported seeing a laser upon AOS of the Earth the first rev after ascent. And we're wondering what color the beam was and if he could determine its approximate location with respect to the Earth. Over.
It was mostly white, perhaps a tinge of yellowish color to it. And it seems to be, as I recall it, the terminator of the Earth was toward the horizon. And seemed to be about a quarter to a third of the way down toward the terminator of the Earth from the opposite horizon. That's a third to a quarter Earth radii. Over.
Roger, and that puts it in the light side. Over.
Roger, yes, it was in the light side. The Earth was about a two-thirds lit Earth, with the terminator down toward the horizon. And now coming from the opposite limb of the Earth, the sunlit limb, coming down about 1/4 to 1/3 of a radius in from the limb, generally centrally located with respect to a line drawn perpendicular to the terminator that goes through the center. Over.
Roger, Buzz, we copy.
And I got pictures of that. I'm sure that'll show up. And I saw that too. It was a very bright spot of light, and I confirmed Buzz's observation of its position.
Okay, 11, very good. Now, with respect to the documented sample container on television, it appeared to us as though the samples for that container were in fact being selected in accordance with some thought or consideration being given to the rocks themselves. And we were wondering if you could give any further details from memory about any of these samples and the context of the material or the surface from which they were taken. Over.
Yes, if you remember, I initially started on the side of the limb that the TV camera was on, and I took a number of samples of rocks on the surface and several that were just subsurface. About 15 to 20 feet north of the limb. And then I recalled that that area had been probably swept pretty well by the exhaust of the descent engine. So I crossed over to the southern side of the limb and took a number of samples from the area around the elongate double crater that we commented on, and several beyond that, and tried to take as many different types of rock types as I could see by eye as I could in the short time we had available. There were a number of other samples that I had seen earlier in our stroll around the limb that I had hoped to get back and pick up and put in the documented sample, but I didn't get those, and I'll be able to comment on those in detail when we get in the debriefing session.
Oh, Roger. Did you observe any small craters with conspicuously blocky rims? Over.
Well, aside from the real big one that we went over, I guess there were none in our area. I took a stroll back after putting up the P7 while Buzz was starting to unpack the documented sample. Took a stroll back to a crater behind us that was maybe 70 or 80 feet in diameter and 15 or 20 feet deep, and took some pictures of it. It had rocks in the bottom of pretty good size, considerably bigger than any that were out on the surface, but there was no, we apparently at 15 feet or so had not got below the regolith. We were essentially showing no bedrock, at least in the walls of the crater at that depth. Over.
Roger, we copy. Okay, thank you, Neil. That about wraps up the questions we have on hand for now.
Okay. My compliments to the chef. The food's outstanding. This cream and chicken soup, I give at least 3 spoons.
Okay, cream of chicken, 3 spoons. Apollo 11, this is Houston, over.
Go ahead.
11, we concur that having Verb 16 Noun 20 up on the Disky may well have had some effect in your PTC initiation. It looks like this would let the computer work with a knowledge of the actual CDU angles. What we'd like you to do is do a CDU 0, which is Verb 40, Noun 20, enter, and then start the PTC procedure again at step 2. With loading Verb 6 Noun 22 desired attitude and the auto maneuver and all that, over.
Okay, the only thing I don't understand about that is why it took off at the rate it did. What rate should it have taken off at under that theory?
Stand by a minute, Mike. .11 CMP, this is Houston, over.
Go ahead, Houston.
Mike, over here on page 9-7 of your checklist where we're setting up PTC, there's been a note penciled in after wait 20 minutes for rates to damp. Do not monitor verb 16, noun 20. It turns out that the significance of that is that if you are monitoring 16, noun 20, then when you get down here in step 7, the second time you do a verb 24, you've got to reload the noun 01 to make it verb 24 and noun 01 enter before you load the 3 registers, over.
Roger that. I was just questioning the rate at which the maneuver would begin if that were not done.
Roger, we're still working on computing the rates for you.
This is Apollo Control at 152 hours, 9 minutes. At this time, the crew is getting the spacecraft set up to reinitiate the passive thermal control. Apollo 11, currently 165,143 nautical miles from the Earth and traveling at a speed of 4,142 feet per second. The flight plan has relatively few activities scheduled for now through the beginning of the crew sleep period tonight. We do have a television transmission scheduled. I believe the time on that is a little after 8 p.m. Central Daylight Time. And we show the sleep period to begin at about 160 hours ground elapsed time, or a little less than 8 hours from now. We'll continue to stand by for any conversation with the crew. It has been relatively quiet for a good part of today. We'll stand by for a call from the Capcom or from the spacecraft down to the ground.
Apollo 11, this is Houston, broadcasting in the blind. If you read us, attempt to acquire on Omni antennas. Attempt to acquire us on Omni antennas if you read. This is Houston, out. Apollo 11, this is Houston, broadcasting in the blind. If you read, attempt acquisition on an Omni antenna. Attempt acquisition using an Omni antenna, over. Apollo 11, this is Houston, broadcasting in the blind. If you read, attempt contact using Omni antennas. Using an Omni antenna. This is Houston, out.
This is Apollo Control at 152 hours, 29 minutes. In the process of reestablishing the passive thermal control with the spacecraft in a slow rotation, we have apparently lost high-gain lock-on. We expect that the crew will reacquire lock with the antenna once the passive thermal control is reestablished. At the present time, Apollo 11 is 164,320 nautical miles from the Earth, and the velocity is up now to 4,156 feet per second. We'll continue to stand by here for reacquisition of the spacecraft for reestablishment of high-gain lock-on.
Apollo 11, Apollo 11. This is Houston, broadcasting in the blind. If you read us, attempt acquisition using an Omni antenna. Attempt acquisition using an Omni antenna. This is Houston out. Goldstone. Apollo 11, this is Houston. How do you read? Over.
Rod clear, Bruce. Tell me.
Roger. What antenna are you using?
Houston, Apollo 11 is calling you on the high gain. How do you read? Over.
Roger. Loud and clear on the high gain.
So what's new?
Oh, we were wondering what was new with you up there.
Oh, very quiet. We're just sitting here letting the thruster firing damp down. When they get good enough, let us know and we'll start this PTC.
Roger.
Nice to sit here and watch the Earth getting larger and larger and the moon smaller and smaller.
Roger, we'll give you a call when your rates have damped down sufficiently. And we're unable at the present time to predict what rate you should have seen at your last attempt to initiate PTC. We saw about 2.5 degrees per second. Over.
Yeah, I believe that. Buzz thinks we should have a PTC program built into the computer. He could very well be right.
This is Apollo Control at 153 hours, 7 minutes. At the present time, we are changing shifts here in Mission Control. Flight Director Gene Kranz will be coming on to relieve Flight Director Clifford Charlesworth. The capsule communicator on this shift will be astronaut Charlie Duke. There will be a change of shift briefing in the news center in the Building 1 auditorium in about 10 minutes. At the present time, Apollo 11 is traveling at a speed of 4,185 feet per second. The spacecraft is about 162,700 nautical miles from the Earth. During the change of shift briefing, we will take the circuit down, record any conversation that develops with the spacecraft, and play it back following the change of shift briefing. At 153 hours, 9 minutes, this is Apollo Control, Houston.
This is Apollo Control, 153 hours, 49 minutes, ground elapsed time. Apollo 11, homeward bound, is now 161,050 nautical miles out from Earth. Velocity now 4,216 feet per second. Some 3.5 minutes of recorded air-to-ground transmissions have accumulated during the recent change of shift press conference here in the Apollo News Center. Let's play that tape back now.
Houston, Apollo 11.
Go ahead, 11.
All right, just checking the radios, and how's the thruster activity coming?
11 Houston, the radios are still in good shape, and we're still waiting for your rates to decay. We've got 0.03 degrees per second in pitch now.
Okay, we're in no rush. This is a very pleasant attitude. As a matter of fact, the sun is down in the LEB, so it's not shining through the windows and heating the place up. We've got the Earth steady out window 1. We have the moon steadily out window 3, and of course we're locked up on the high gain. So as long as the thermal people are happy, we're happy.
Roger, we copy. Apollo 11, this is Houston, over.
Go ahead, Houston.
Okay, 11, we're about ready to start PTC. I'd like to give you some high gain antenna angles. Well, we'd like to operate in the react mode, and do you plan on spinning up in the positive or negative direction, over?
We can do it either way. I had planned the positive.
Okay, for positive, the high gain antenna setting should be pitch plus 30, yaw 270, and in react. Over.
Understand, react, pitch plus 30, yaw 270. Thank you.
Roger, and if you would, when you're making your DSKY entries to set up for PTC, go a little slower, and we'll try to follow each entry from down here, over.
Roger that. Houston 11, PTC established.
Roger, 11. Hi, 11, Houston. We observe the PTC to be fairly well established here, and we'll keep you posted on how it's going. And your friendly white team commentator is taking over now.
Okay, thank all you black team.
That was the green team.
Correction, now you green team. Correction, green team, excuse me.
Roger out.
How could I forget? I used to be a green one.
Hello, Apollo 11 Houston. Your white team is now on. We're standing by for an exciting evening of TV and a free sleep report, over. Apollo 11 Houston, you sure you don't have anybody else in there with you?
Houston, Apollo 11, say again, please.
We had some strange noises coming down on the downlink, and sound like you had some friends up there.
Where'd the white team go during their off hours anyway?
Say again? This is Apollo Control. Still no explanation. The weird noises emanating from Apollo 11, if indeed it is from Apollo 11, and it's reported from network that it's being received on the downlink at two different stations in the manned spaceflight network. Perhaps we'll all shake out later in the mission as to what these strange noises are. We'll come back up again as conversation is resumed with Apollo 11. Now 160,410 nautical miles out from Earth, traveling at 4,228 feet per second. At 154 hours, 5 minutes ground elapsed time, this is Apollo Control. This is Apollo Control. 154 hours, 53 minutes. Ground elapsed time, 40 hours, 9 minutes to entry. Apollo 11, homeward bound, 158,378 nautical miles out from Earth. Velocity now 4,267 feet per second. We have some 3 minutes of tape accumulated over the past half hour of rather minor conversations with the crew of Apollo 11. We'll roll these tapes now.
Apollo 11, Houston, over. Roger, would you we've lost comm with you for about the last 10 minutes. Would you verify that the S-band track switch is in react, over?
Negative, it's not. Last time we went to auto and I left it there. Sorry.
Roger, we'd like to have you to put it in react and monitor. In about 2 minutes we'll be coming up on the high gain. Would you monitor the react? If it doesn't take, acquire manually, over.
Okay, take any angles you'd like.
We'll try to switch it ourselves. Stand by on the angle. Buzz, it's pitch plus 30, y'all 270, over.
Roger, got him.
Thank you. Hello, Apollo 11, Houston, would you please terminate battery charge now, over?
Roger, terminating battery charge.
Hello, Apollo 11, Houston, any special attitude you'd like us to look at for the TD, over?
I don't guess we have a requirement there, John.
Roger, we have any attitude that we can get the Earth out of a window, or the moon. We're trying to find one that we can get both, if that's what you'd like, over.
Our 50-degree roll attitude will probably give us that, John.
Roger.
That's a good one because it puts the Earth out window 1 and the moon out window 3, and it puts the sun down the LEB, so the lighting in here remains relatively constant.
Roger, well, we'll just stop on the 50 roll in, and we'll give you the word when to do that, over.
Okay.
This is Apollo Control, and that completes the accumulation of air-to-ground communications by means of tape recordings over the last half hour or so. It's quiet right now. No conversation going on between spacecraft communicator Charlie Duke and the crew of Apollo 11. And at 154 hours, 57 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 155 hours, 27 minutes ground elapsed time. Coming up now about 3 minutes away from the tonight's television pass. It'll be through the 85-foot antenna at the Goldstone tracking station. The 210-foot dish out there is tied up tracking one of the Mars flyby missions. We have some 20 seconds of tape accumulated. We'll play that back and rejoin the conversation live.
Apollo 11, Houston. We'll have high gain coverage about 155.30 that time. You can turn on the TV if you desire and continue your roll around till you get 50 degrees roll. Over. Apollo 11, Houston, we're going to give you the All-Star game tonight, but it was rained out. Over. Houston, we're on a high gain. You can warm up the FM if you'd like. Over.
This is Apollo Control, still standing by for the incoming television signal from Columbia. Still nothing but the color bar test pattern as of now. Continuing to stand by on air, ground, and television links.
Apollo 11, Houston, we see you coming up on 50 roll. How does that attitude look? Over. Apollo 11, Houston, we're ready for the TV. We're all configured at your convenience. Over.
This is Apollo Control. While we're waiting for the television pictures to come in, we have in the control room here a vase full of long-stemmed red roses with a card saying, "To one and all concerned, job superbly done, from a moonstruck Canadian." Continuing to stand by as we wait for the pictures to come from Columbia. Here they come.
Houston, Apollo 11, over. Roger, go ahead, 11, over. Are you picking up our TV signal? That's affirmative. We have it up on the IDA-4 now. The focus is a little bit out. We see the Earth in the center of the screen. Still have a little white dot in the bottom of the camera, apparently. And see some land masses in the center. At least I guess that's what it is. It's very hazy at this time on our IDA-4, over. Let me change. I believe that's where we just came from. It is, huh? Well, I'm really looking at the bad, at a bad screen here. Stand by one. Hey, you're right.
Not bad enough. Not finding you on the right landing spot.
What?
It's not bad enough not finding the right landing spot. We haven't even got the right planet.
I'll never live that one down.
We're making it get smaller and smaller here to make sure that it really is the one we're leaving.
Oh, that's enough, you guys. Eleven, that was a good picture.
Okay,
there.
that's enough of the moon. Okay, that's enough of the moon jelly. We're getting set up now for some inside pictures.
Right.
We know there's a lot of scientists from a number of countries standing by to see the lunar samples, and we thought you'd be interested in seeing that they really are here. These two boxes are the sample return containers. They're vacuum-packed containers that were closed in a vacuum on the lunar surface, sealed, and then brought inside the LEM and put inside these fiberglass bags, zippered and resealed around the outside, and placed in these receptacles in the side of the command module. These are the two boxes, and as soon as we get onto the ship, I'm sure these boxes will immediately be transferred and delivery started to the lunar receiving laboratory. These boxes include the samples of the various types of rock, the ground mass of the soil, the sand and silt, and the particle collector for the solar wind experiment, and the core tubes that took depth samples of the lunar surface.
Roger, Neil. Thank you much for that description. We've got a pretty dark picture down here. Could you check your f-stop? We'd like to have it, see if you could open it up a little bit, over.
Okay, our monitor showed that to be very bright. We're down around around F4, which we thought would be plenty light. We'll lighten it up some more.
Well, we'd appreciate it. It's pretty dark on all our monitors here. Okay, fine. That's looking a lot better now, Neil. There's Buzz. Houston, we have an excellent picture now, over.
How do you read me, Charlie?
5 by now, Buzz, over.
Okay. More mundane affairs. Now that we've left the moon, I'd like to trace through a little bit for you. Development that has taken place in the food department. I'm sure you've always type of a drink container. A little later, Mike will show you how the water gun operates with its new filter to take out hydrogen. Essentially, this water gun is put in this end and filled up this bag with water, and the drink then dissolves in the water, and this end of the outfeeding. Likewise, we have other foods that are more solid nature. You can probably see this shrimp cocktail meal. This afternoon, while the two of us had salmon salad. Another early development was the use of bite-sized food.
11, Houston, Buzz, you're breaking up badly. Would you check your box, over?
All right, how am I coming through now, Charlie?
Roger, you're very clear when you come through. It's just that your box is not keying at every word, over.
Okay. These bite-sized objects were designed to remove the problem of having so many crumbs floating around in the cabin. So they designed a particular size that would be able to go into the mouth all at once. I think since all of our experience, we've discovered that we can progress a good bit further than that back to some of the type meals that we have on Earth. As a matter of fact, on this flight, we've carried along pieces of bread. And along with the bread, we have a ham spread. And I'll show you, I hope, how easy it is to take some ham environment of 0G. We've discovered that it is quite easy to all very familiar with it.
Apollo 11, Houston, we notice your roll rate increasing. Will you please see if you can bring that down to about 0 for us? So we'll be losing a high gain shortly, over.
We can also use zero gravity to demonstrate many things that we've all learned in school. I'd like to demonstrate briefly how easy it is to explain the action of a gyroscope. If I spin this can, we know that according to the equations of motion, that we would expect that if once this is given a spin and has a spin axis in this direction, if we give it a particular torque, and I'll do this by pushing my hands against it in this fashion once it's spinning, by the equations we can predict that as I put this torque on it, it will in fact rotate this direction. Let's see how well this works out. As I applied the torque this way, it rotated this way. Too close.
Houston, it's a pretty good demonstration.
Houston, this next is a little demonstration for the kids at home, all kids everywhere for that matter. I was going to show you how you drink water out of a spoon, but I'm afraid I filled the spoon too full, and if I'm not careful, I'm going to spill water right over the sides. Can you see the water slopping around in the top of the spoon, kids?
That's affirmative, 11.
Okay, well, as I say, I was going to show you, but I'm afraid I filled it too full, and it's going to spill over the sides. I tell you what, I'll just turn this one over and get rid of the water and start all over again, okay?
Okay.
And you can see up here we don't know where over is. One up is as good as another. That really is water, though, I'll show you. That's really not the way we drank. We really have a water gun, which I'll show you. Here's the water gun. This cylindrical thing on the end of it is a filter with several membranes. One allows water to pass, but not any gas. The other allows gas to pass, but not any water. So by routing the gaseous water, which comes from our tank, through this filter, we're enabled to drink purified water without the gas in it, filtered water. And, of course, all we do to get it started is just pull the trigger. sort of messy. I haven't been at this very long. It's the same system that the Spaniards used to drink out of wineskins at bullfights. Only I think this is even more fun. Well, be seeing you, kids.
Thank you from all the kids in the world here in the Moker who can't tell the Earth from the Moon.
All right, just stand by one and we'll get you that Earth for you.
Looks like you need a wineskin up there, Mike.
That'd be nice. Okay,
K11 Houston, I have a picture now. That's affirmative. I refuse to bite on this one, though. You tell us.
okay, this should be getting larger, and if it is, it's the place we're coming home to.
Roger.
No matter where you travel, it's always nice to get home.
We concur.